Okay, let's make sure we're recording. So going to share my screen. Oops. There we go, webinar. Okay, so good morning, Year 7. For those of you that don't know me, I'm Miss Clayton. There are a few of you in here that should be in my classes, so you all know me. But just to start with, I've put some do now questions on for you. So this lesson, we're going to be looking at acids and alkalis. Some of you would have done this before with your teachers. Some of you, this will be completely new. Some of you might have just started. So we're going to be going over all the bits to do with acids and alkalis today. So have a little look at these do now questions. The first three, or the first three questions we looked at in our webinar last week. So looking at our hazard symbols, our states of matter, and describing our particle arrangements. Have a little go at answering these questions, not putting these in the Q&A box. Just think about these for yourselves, see what you can remember. And then question 4, we're thinking about what you think of when you hear this word acid. What are some of those words that you might think of? Just going to give you a couple of minutes to think about these. Okay, so what would these hazard symbols be? Our states of matter. And then what we think when we think of acids. Okay. So I'm sure loads of you have been able to get question 1. So we had some symbols here. This one here is our symbol for corrosive. Then we have toxic, and we have flammable. So those are 3 hazard symbols that you're going to see on lots of things that you use in the lab. Then we had our names of our 3 states of matter. So I'm sure most of you would have got this as well, but we had our solids, our liquids, and our gases. And question 3, describing our particle arrangement. So we wanted to talk about how those particles behave in a solid, how they behave in a liquid, how they behave in a gas. So for our solids, you wanted to say that they were tightly packed, they couldn't move around each other, they'll just vibrate on the spot, they can't be compressed. Then we had our liquids, so they can move around each other, they're still tightly packed, but they still can't be compressed. And then our gases, so these are really randomly arranged, they can move around freely in the space, and they can be compressed together, so there's lots and lots of space between them. Now, words we might think of when we hear acid. So when I did this before, we came up with words like burning, dangerous, we came up with corrosive and damaging, different words like that. But we also came up with words like lemons and vinegar and things that we might find at home. They're also acids. So acids and alkalis is what we're going to be looking at today. So before we get going, I'm just going to go over again what our home learning will look like for Year 7, because we did have a few questions at the end of the webinar last week. So just want to make sure that we all know what we're doing. So on the screen, the bottom right here, I know that most of you have already found this. You have the section for your Q&A box. So that is where you click to ask any questions, and Miss Tomlinson will be replying to those for you. So your webinars are going to be given live like they are now, but they're also going to be recorded, and your teacher will put these into your Google Classroom for you so that you can look back and have a little look at anything that you want to have another look at. So you're going to have one webinar at this time each week, and then a 45-minute session afterwards to do the work that is set by your teacher. This will include a Google quiz, which is the same as what you do for your prep. So we should be able to do those. And like I said, your work will all be set in the Google Classroom. Google Classroom codes here again. So if you need to find your Google Classroom code, this is here. If you're not too sure of it still, I think most of you are in your classrooms now, but if you do need to check back, they are here for you. So for today, after you've watched this webinar, you'll have some work in your Google Classroom. to complete. Like we said last week, we're not expecting every single person to finish all of the work, but we do expect you to have a really good go and attempt the tasks that you can do. We still do have high expectations of you, and you should have high expectations of yourself as well. But we only want you to work for 45 minutes after the webinar. So watch the webinar first, then work for 45 minutes, stop there and submit what you've done. You don't have to keep going after that 45 minutes. So your list of things to do today and your order of things to do today. First of all, watch the webinar, which you're doing now, which is great. Need you to complete your Google quiz second, which will be in your Google Classroom. There's then 3 separate question sheets. So you've got question 1, question 2, and question 3. Everybody should try and do question 1, then most try and do question 2. And then there's question 3, which is a bit of more of a challenge there as an extension. Like I said, just what you can do in 45 minutes. And then at the end, there is an optional practical if you can have an adult to help you with this, but I'll talk about this in a second. Okay, so today's webinar, by the time we get to the end, we're going to be able to answer 3 questions. So we're going to be able to say what acids and alkalis are. We're going to describe how we could test whether something is an acid or an alkali. And we're going to be able to say what is meant when acids are described as strong and weak, and as concentrated and as dilute. So we're going to be able to define what those 4 ways of describing an acid or an alkali are. So to start off with, what are acids? So an acid is anything that has a pH less than 7. And we're going to talk about pH shortly, about what that actually means. But an acid is something that has a pH less than 7. They can be corrosive and they can be irritating. So they can damage your skin, but then they can also damage metals. Or they could just make you have a little bit of an itchy, irritated skin if it is more of an irritant. Now we're going to find these in the labs, and the ones that we find in the labs are going to be a bit more harmful, but you can find them in your home as well. So this picture on the screen, we've got some lemons, we've got some limes, we've got some vinegars. They are all types of acids. So we've said that a pH is something, an acid is something with a pH less than 7. What this means is that an acid is a solution, and when you dissolve that in water, it gives off something called a hydrogen ion. And a hydrogen ion is this H+. So something that is acidic will have a solution with lots of H+ ions in it. Okay, so we've said acids are not always damaging. They're not always gonna burn through tables. They're not always gonna burn your skin. They can be useful. So we have some acids at home. We can find these in our citrus fruits. We're going to find them in vinegar. We could find them in our salt and vinegar crisps. In fizzy drinks, you're going to have carbonic acid in your fizzy drinks. Lemons full of citric acid, and vitamin C is something called ascorbic acid. So you'll find that in your oranges. You'll also find acid in batteries. Now, the acid in your batteries is a bit more harmful. That is more of a strong acid. So you need to be careful with battery acid and not to ever touch battery acid. And then again, this picture here with the vinegar. Now on to alkalis. So what is an alkali? Now, an alkali is something with a pH that is greater than 7. Like I said, we're going to have a look at what pH is in a minute. We can see that we've got different types of alkalis here. So sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide. We can see that they've got this hydroxide in their name. Also got alkalis at home. So we've got bleach, we've got cleaners, we've got antacid tablets, toothpaste, baking powder. They all are alkalis. And an alkali is something that when it's in a solution and dissolved with water will give off these hydroxide ions. So these OH groups here, the hydroxide groups, are going to detach from the rest of their group. We're going to have those free in our solution. So the symbol for our hydroxide ion is OH minus. So alkalis, anything with a pH above 7. Okay, we've got a few quick questions to do now. So Miss, on the bottom of your screen, there should be, oh no, I've got it here, don't worry. So polling. So if you can just answer these couple of questions here for me, which I'm going to pop up. They are completely anonymous. So you just have to put what you think, and it'll be completely anonymous, and it will come back to us to see how you do. So have a go at these questions. Just one answer for each. So an acid is a substance when dissolved in water will lose what types of ions in our acids? What types of ions will our alkali lose? And then an example of an acid that we might find at home. Okay, we've got some votes coming in. I'll give you about another 30 seconds to do these, I think. 30, 40 seconds to do these. Okay, 50% have voted, so about another 15, 20 seconds. Okay, so I'm going to end that poll there. So most of you had voted, really well done. So great, most of you remember that acids will lose their H+ ions and the alkalis will lose their OH- ions. Really, really well done. Great, most of us saw that an acid that you'd find in your home would be lemon juice. So well done, guys. Okay, moving on then. So I talked about pH. I said that anything with a pH that's less than 7 is acidic, and anything with a pH of higher than 7 is an alkali. And as we go further away from 7, they become increasingly acidic or increasingly alkali. So this is our pH scale. It tells us how acidic or how alkali a substance is that we are testing. It gives us a number. And we can also come up with this rainbow looking scale using something called an indicator. And this thing called universal indicator will give us these colors here. So where we have red at our 0 end is showing us that we have a really strong acid here. It moves through orange and yellow as we get to weaker acids and back towards this neutral. Then when we get to 7, that's neutral. So 7 is something that is neither acidic nor alkali. Something like water would be there in the middle at neutral. Then we keep going all the way through blues and purples. So we're getting increasingly alkali as we go through there. So we're getting more of our OH- groups being lost and being in our solution. Okay, I filmed a little clip for you with a little practical demo that I've done in school. So I'm going to play this for you. It's about 3 minutes long, and you can go back and watch this again because it will be in your Google Drive. So let's just watch this clip. In this clip, I'm going to talk to you about the pH scale. So as you can see on the screen, we have what looks like a very pretty rainbow with the numbers above going from 0 to 14. But what do these mean? Now, these colours are made using something called a universal indicator. And the universal indicator will change different colours when put into different solutions based on whether they are strongly acidic, strongly alkali, weakly acidic, weakly alkali, or neutral, meaning that they are neither acidic nor alkali. Now, I've set up a little demo for you here. I have 3 test tubes. One with some hydrochloric acid, one with some water, and then finally one with some sodium hydroxide. Now let's see what colour this indicator will turn these solutions. So I'm going to start with water and add a few drops of my indicator. So we should be able to see that that turns green. By turning green, this signifies that it is a pH of 7, which means that this substance is neutral. I'm going to do the same for my hydrochloric acid. And we can see that this time it turns red. Now this is telling me that this substance has a pH of around 1 to 2, which means that it is a strong acid. Now finally, I have my sodium hydroxide, and we can see that this turns purple. Now this means that this is a strong alkali. To give you a little bit more of a close-up there. So we have red, green, and then very, very dark purple. So let's add this to our pH scale on the board. We can see that our hydrochloric acid turned red, so we have acid, and our sodium hydroxide turned purple. That's an alkali, so that means that purple is showing us that something is alkali. And finally, in the middle, our green colour, this is neutral. So this is where we find water. Now, remember, this is just the universal indicator, which is what we're most commonly use in school. There are some other indicators out there, so just make sure that when you're talking about these colours, you're talking about universal indicator. Okay, so universal indicator shows us the pH of a solution based on color. So we put our universal indicator, which is a chemical, into our sample, and that will be able to tell us what pH it is, because we can link it back to our scale here. So if it turns red, we know that it's acidic. If it was to turn purple, we would know that it is alkali. Okay, so we can use our universal indicator to test lots of different things. So there's a selection here of substances which are acidic and alkali. So you can have a little look at this later. There's some quite interesting things here, things that we would see in normal everyday life, and whether they are acidic or alkali. So this is using our universal indicator that we get these colours. Now, Mrs. Tomlinson has filmed another video for you using a type of indicator that you can make at home. So we can make another indicator using cabbage water, and the cabbage water will again turn different colours when it's put into different substances. So you can have a little look at this video. It'll be in your Google Classroom if you want to do this at home. So I've said if you do this at home, have a little look on the image on the previous slide. So this picture here, maybe you can test some of these things that you might have at home and see what colour they change. Okay, other indicators that we can use as well. We have something called litmus paper. So we'll have red litmus paper and blue litmus paper. Now, these will only tell us whether it is acidic or alkali. It won't tell us necessarily the strength or weakness of the acid or alkali. So it's just going to tell us in general whether it is an acidic substance or an alkali substance. So if we were to use red litmus paper and we pop it in an alkali, it will turn blue. If we put it into an acid, it wouldn't change. Blue litmus paper, if we pop it into an acid, it will turn red. That is telling us that that liquid is acidic. If we pop into an alkali, it wouldn't change colour. It's a little optional research challenge for you to do here if you want to, and you've got time at the end. Can you find out about any other indicators that we can use? So universal indicator is one that we will most commonly use in school. You might also see litmus paper, and then you can use cabbage water at home. There's some other ones that we can use in the lab and some other that we can use at home. So see if you can find out about any of those.
Miss, were you going to show the video?
I can do. I was going to leave it to watch at home. I can pop it now.
It's all right. Let me see what the student. I mean, they can watch it at home. Then that's fine.
I just didn't know because I'm worried about time.
That's all right. No, the students were just asking. That's all right.
Yeah, if we watch it at home, just because I'm worried about time, because you guys have got other things to go on to. Is that okay, Miss?
Yeah, that's fine.
Yeah. Okay, it is on there for you to watch afterwards, guys. Okay. So another quick poll for you to do. So let's go here, indicators. Have a little go at answering these questions here. So question 1, what does the pH scale show? There's 4 options there for you. When the universal indicator is put into water, what colour will it turn? And if it's put into a strong alkali, what colour will it turn? And if it's put into a strong acid, what colour will it turn? So I'm going to give you about 30 seconds to have a go at this question. Okay, about another 10 more seconds. So try and have a go at these questions. Okay, let's end that there. So fantastic. Most of us saw that the pH scale does show how strongly acidic or alkali something is. Universal indicator will turn green in water. In a strong alkali, it will turn purple, and a strong acid, it will turn red. Fantastic, guys. So let's move on. So this is a little bit of an extra, more complicated explanation here. You guys don't need to know this, but I know that there are some of you that would be interested to know this. So this slide is on the Google Classroom for you as well. Just talking about these ions. So something that's neutral will have this equal amount of these hydrogen and hydroxide ions. If it's acidic, we're going to have more hydroxide ions, sorry, more hydrogen ions than hydroxide ions. And if it's alkaline, we're going to have more hydroxide and less hydrogen ions. So you can see in these little pictures here. This is just something for you to have a look at. Like I said, you don't have to know this. So now we're going to talk about strong and weak acids and alkalis. So we mentioned this before, and this is something to sort of remember here what strong and weak actually means. So a strong acid is something that will lose its ions quite easily. So we have these hydrogen ions that are in our acid molecules. So we can see in this picture on the right that our acid molecules are these little blue and red circles that are joined together. If the hydrogen ions in an acid are lost quite easily, then that is a strong acid. So we can see in the little picture on the left that all of our ions have detached from each other. They're all on their own now. So that's a strong acid. On the right with our weak acid, we've only got a couple that have broken apart and lost their ions. They've only a couple have dissociated. So our weak acid is only going to have a few of our free ions there. So strong acid or alkali is one that will lose its ions more easily. And a weak acid or alkali won't easily lose those. So a solution that is strongly acidic or strongly alkali will have more free ions there. So on our pH scale, our strong acids and alkalis are going to be more towards those 0 and 14 ends, with our weaker ones more towards the middle. So just one more quick bit here. So we've got dilute and concentrated, which we also need to know. So a dilute solution is something where we've got just a few acid or alkali particles and lots of water. And then a concentrated one is where we have more acid or alkali particles and just a few water particles in the solution. So a way to think about this is if you think about your squash that you might have at home. You've got blackcurrant squash, and it'll say on the bottle that it's a concentrate. So it's got lots and lots and lots of particles there. Lots and lots of blackcurrant particles, if these are going to be our acid particles. When we mix this with our water, we're adding more water in there. We're going to have fewer blackcurrant particles than we're going to have water. So we're making this more dilute. So this picture on the bottom left of the screen here, we've got a diluted solution. You can see that it's a much lighter colour. So that means we've got fewer blackcurrant particles, and it gets darker and darker as we get more concentrated. So the concentrated has more particles of the blackcurrant and less water in there compared. You can see this on the right hand side picture where we've got the pink little dots are showing our acid or our alkali particles in our water. So you can see that the concentrated solution has more acid or alkali particles compared to the water. So last bit here to look at, we're comparing a particle model of our concentrated acid and dilute acid. So I've got two sentences here, and I want you to tell me which of these sentences will describe the concentrated and which will describe the dilute. So have a little go at this poll for me. So which sentence is describing concentrated acid, A or B? Which is describing the dilute acid, A or B? Okay, about another 10 seconds. Okay, let's stop there. So let's have a look at what we said. So which statement best describes a concentrated acid? So most of you here said B. So you said that the acid has a lot of acid particles compared to water particles. Yeah, great. So the acid, the concentrated acid here was sentence B. And then sentence A, the dilute acid is an acid where there are only a few acid particles compared to the water particles. Okay, something for you to have a little look at afterwards. We've got this really cool pH scale simulator. So if you can't have a go at that practical at home, have a little go at this. You can test the pH of some different substances, including vomit, which is super gross. But if you click on this link and then click on macro, you can have a little look at there. Have a little look at what you notice when you add more water. What happens to the pH? Okay. Oh. Okay, so to summarize, today we have learned that we've got acids or anything that's a pH of less than 7, and an alkali has a pH higher than 7. A pH of 7 is something that is neutral, so it's neither acidic nor alkali. That in the middle, we would find our water. So the colour scale here, we would get using something called universal indicator, and our indicators change colour based on whether something is acidic or alkali, and it will tell us where on that scale it will land. Okay, Miss, did we have any questions to go over?
Not really, actually. No, I think that's okay. I'll direct students then to those of you who asked. We'll upload the video of the red cabbage indicator so you can watch it to help you through. One student has said your hair could have gone in the acid. I think Miss was all right. Those of you asking if the work isn't in the Google Classroom yet, it will be. I'd give it 15 minutes and I bet it's there. It depends who your teacher is on what the main task is for that other question. So the work within the next kind of 20 minutes will be in the Google Classroom for all of the groups, would be my guess. And your teacher will give you direct instructions for that. I don't think, let me see one more question. Just students saying hi. So hi students.
Hello.
That's it. So I think that's all, Miss.
Okay, fantastic. Well, just to summarise in quickly again, because we had those questions, just back to our first slide that we had, just work for 45 minutes. Like Ms Tomlinson said, that main task might be slightly different on your teachers. First of all, though, do your Google quiz, have a look at those questions, and then I've put on the bottom here that you do have this optional practical, and the video will be in your Google Classroom. So you can have a little look at that video if you want to give that a try at home. Okay, thank you for listening, guys. Have a lovely day. And if you do need anything, just ask. Okay, we're good. I will stop recording. How do I stop recording?